Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Denis Zakaria, and my team and I will present about our lab topic, which is a running light with a difference delay. I will present about the question, schematic diagram, and also the GPIO configuration table. So our team take the topic in the question 2, which is in the question instead to write the and execute assembly program that turns the LED 0 to LED 7 connected to the port PC 0 to the PC 7 one by one from LED 0 to LED 7 as a running light with 3 different times delay, which is 2 second, 0.5 second, and 0.1 second when the switch B1 user button is pressed. So basically the question 1 is when we press the button, the LED from the LED 0 to LED 7 will on as a running light, and when we press the button again, so it will change the delay, which is in the default delay is 2 second. Next delay is 0.5, and the next delay is 0.1, and it continue loop. For schematic diagram, the input push button is connected to the PC13 and act as the active low input, and for the output for the LED, use the pin out PC0 until PC7 and act as the output of active high. Continue to the GPIO configuration table. Start with the RCC AHB1ENR, which is as in the schematic diagram. We just use the port C. So in this RCC AHB1ENR, we choose the port C only, and then in the binary we will get the 100, then change it to the decimal form, we get a 4. For GPIO-C model, for the output, we have two table that we need to be considered, which is BIC and ORR. So as we know, BIC use the value 11, and the OR use the value of the 01. So as we know, the output have the 8 output from 0 to the 7. So in the BIC, we select the 11 in the mode RO0 until mode R7. So in the if we change it to the hexa form, we will get the value of 0x000FFFF. For the ORR, we use the value of 01 for every mode output that we use. So from the mode R0 to the R7, we use a 01, and then we change it to the hexa form. We will get the value of 0x00005555. For GPIO-C model input, we just use the BIC, which is PC13. So in the mode 13, we choose we put 11 at the 27 and 26. So we get the hexa number, which is 0C000000. For GPIO-C IDR, for the input PC13, we need to masking because we want to focus on one pin. When register have 6 different pins, masking allow CPU to look at only one specific pin. For example, like this lab, which is PC13, so it will ignore the rest. So for the masking, we will choose the IDR13 as a height, which is 1, and others will be the 0. So we will get the value in a hexa form, which is 0x00002000. And for the push button, when it push, the IDR13 will be the 0 in this lab, it is the active low condition. That's why the IDR13 is 0. So the others still remain 0, which is close. But in the IDR13, it's 0 means that it's on. So that's why we get the value for the when push button push is in the hexa is 0x00000000. And for the lastly GPIOC or DR, that we find the configuration for the pin out for every output in this lab. For example, like LED, when LED 0 is on and the others will be off, we will choose the ODR R0 as a height, as we know the output is the active height and the others remain 0. So we'll get the value of 0 at 0001 and continue with the LED 1 on, then others will be off. So we will put the height on the ODR1, and then we will get the value of LED 1 when it's on and others off is a 0 at 00002. And continue with the LED 2, we select the ODR2, so we get the binary numbers is 100. So we change to the hexa, we get the 0x0004 for LED 2 situation configuration. And LED 3, we put on the ODR3 1000, which is when we change it to the hexa form, we get the 0x0008, 0x000008. And then for the LED 4, we put the height on the ODR4. So we will get the value of 10000, and then change to the hexa, we got the 0x000010. And for the LED 5, we'll put the height value to the ODR5, which is we will get the value of 10000. We change it to the hexa form. LED 5, we get the 0x00000020. LED 6, we put the height, active height to the ODR6, and we get the value for the LED 6 to on and others remain will close, which is 0x00000040. And for the LED 7, we put the active height on the ODR7 and we get the value of 0x00000080. So this configuration for the output to the LED based on their pattern, like when LED 0 is on and the others will remain off. So we get the value that we want and continue with the next LED, which is LED 1, LED 2, and act as the running light.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Masri and I will explain about flowchart. When the program is start, it will initialize the system clock enable GPLC clock. It will configure PC0 until PC7 as output, which is LED, and will configure PC13 as input, which is push button. The program will read the push button. If no first push, it will read again the push button. But if has first push, LED 0 will on and others off. It will delay for 2 seconds. It will shift to next LED until LED 7 to perform the running light. If no push button push again, LED 0 will on and others off. But if yes, LED 0 will on and others off. It will delay for 0.5 seconds. It will shift to next LED until LED 7 to perform the running light. If no push button push again, the LED 0 will on and others off and will delay for 0.5 seconds. But if has uh, but if the push button is pushed again, the LED 0 will on and others off and it will delay for 0.1 seconds. It will shift to next LED until LED 7 to perform the running light. If the push button not push, the LED 0 will on and others off and it will delay for 0.1 seconds. But if the push button is pushed again, it will delay for 2 seconds. The program will repeat.
Assalamualaikum warahmatullahi wabarakatuh. My name is Umar Naufal and I will be presenting or explaining about our coding for the running lab. So in the main function, as you can see, to enable the GPIO clock, particularly the GPIOC clock, we load the RCCH B1ENR into R4, and then we load the value of R4 into R5, and then the ORR is port C is with the value of 4, as we can be obtained from the table before, and then we store back the value of R5 into R4. And then the second one is we want to configure the port C from 0 to port C7 as output, and also PC13 as input. So the output will be LED and PC13 input will be our push button. So we load the value of C00FFFF, which can be obtained from the input and output from the table, and then we load into R5, and then we use the instruction BIC for input and also output. So for output, the value of 555 can be obtained through the table, which the output requires BIC as well as ORR. So for this one, there is also ORR included. So we load R1 for the value of 5555, and then we ORR with R5, and then we store back the value of R5 into R. Okay, so for the second part, there are two parts mainly, which is the start button press and the start button release. So this ensure that when the button is pressed and released, will then and only then the LED will start shifting. So by holding the start button or the push button, will not execute the command to light up the LED and start the shifting LED. So when the start button is pressed, GPIOC IDR is loaded into R10, and then we load the value of R10 into R11, and then the value of R11 is tested whether it is 0x2000, which indicates the button has been pressed. If it doesn't equal to 2000, it will return back and waiting for the button to be pressed. So for the start button release, we load the value of current value of R10 into R11, and then we test again if it is equal to 2000, which means the button has been pressed, if it does equal to start and the button is if the button is still pressed, it will return again into the start button release. So after the button has been released, it will go to the main function ulang, which we load the output into R4, and then the value of R8 is moved to 0x01. So at this point, the LED has started shifting. So for the initial speed state, there are three states that we have declared initially. So for 0 is 2 seconds, 1 is 0.5, and 2 is 0.1. So as can we see here, initially the value of R6 is 0. So the initial speed state and the delay between LED to another LED is 2 seconds. So R7 is the value of delay. So for one chunks it's 10 milliseconds. So for 200 it will equal to 2 seconds for each. Okay, so for this part, we will discuss on the shift LED and also the ulang delay. So the shift LED is quite simple. So the value of R4, which is the output value, is stored into R8, which is the current LED, and also the R7, which is the speed state. We move the value of R7 into R9. So ulang delay is used to check the press of the button for every 10 millisecond. So this ensure a very smooth and efficient uh, hardware design. So for the first one, we load the value of input R10 into R11, and then we test the value of R11 for the value of 2000. So for this part, this is essentially just to test for the button press. So this is essential for the CPU to read if there is a button press. This is quite the same mechanism as the first part, where we wait for the button press. So if the system detected a button press, which is the value of 0x2000, it will go to the function change speed, which will be discussed later. So if not, it will wait for another 10 seconds, and then it will check again for ulang delay. So it will continuously check for each 10 second. The system will be much more efficient with no lag. So this is essentially how the LED shifted from one to the other. So for the first LED, the value is 0 x 000 0001. So and then we will apply the logical shift left to shift the value, and then it will store the value into R8, which is now the LED is now 0x 00000010. So the second LED is now light up. So it will continue to shift and compare the value until the last LED, which is on PC7, which is 0x100, which is the last LED. So when the value is still not 0x100, it will return again into shift LED at the top, and it will repeat again all the process. So after all LED have been light up, it will go again to the ulang. Okay. Okay, so for the last part of the program, I will explain on how the LED change speed from one to the other. So, based on the slide before, when the button is pressed, it will go to the change speed function, which is here, and then it will check for the button hold. So, button hold is essentially the same as button release. So, it will wait for the button to be released, and then it will execute the next instruction. So as I stated before, R6 is the speed state, which is 0, 1, and 2. 0 is 2 second, 1 is 0.5, and 2 is 0.1. So the current value is 0. So and after the button hold, it will add the value of R6 by 1. So from 0, it will be 1 now. So it will compare until the value is 3, and if it is greater than 3, and then the value of R6 will be resetted again into 0. So the change of speed is 2 second, 0.5, 0.1, and after the next button press, it will return to 2 second again. So the next one is essentially how we detect the current value of R6 and set the speed of the shift of LED. So for the first one, we will compare if the R6 is equal to 0, and if it is equal to 0, it will go to the function set to second. So for the set to second, the R7 value will be declared as 200, which is 200 times 10 millisecond, which is 2 second. So for the next one, to check is if R6 is equal to 1. So if R6 is equal to 1, it will go to set 0.5 as 50, which is 0.5 millisecond. So lastly, if not, it will by default R7 is equal to 10, which is 0.1 millisecond. So after all this, it will return back to the function ulang. So lastly is only the delay routine, and then the program ends here.
Next, I will show the video of the hardware demonstration. When the push button is pressed, the LED will running for 2 seconds. And then when the push button is pressed again, the LED will running for 0.5 seconds. And when pressed again, it will running for 0.1 seconds. And when the push button is pressed again, the program will reset. and will repeat the delay. That's all from our group. Thank you.